Hello everyone, welcome back to another video for the series. I'm Inohyu and today I brought a geometry problem, and that is because I think we're like almost halfway there. Today 100 and day 100, and I have exactly 60 days. So 60 days for KMO. And I don't know, like, we all know that we have algebra. Why is my... We all know that we have algebra, number theory, algebra, geometry. I'll just follow the convention. We have these four subjects, but I know that I need to trash this. And I think I also need to trash this because we usually have this on problem 3 and 4. Like, I would be so unlucky if number theory is in number 1 or 2. That means I need to solve it, but it's I think it's likely that it will come out in 7 and 8 and 3 or 4. And combo is the same, it's usually 3, 4, and 7, 8. It's so unfortunate if there's an algebra problem in number 8, because that means I'll be losing a problem that I'm most confident in. But I'm hoping that will not happen. 5 and 6. I will be studying more on, which means I'll be making more videos on algebra and geometry, because combination, no matter how much you study, if you can't like think of one idea during the test, then you just can't solve the problem. And I think you will notice that. If you look at the problem, then we know we cannot solve the problem, so it's not a problem for me. So that's why I would just like not look at combos. And number theory, like, we really need to learn lots of things. I mean, I studied mod, like, and other mod related theorems like Wilson's theorem, Fermat's-Little theorem, Euler's theorem, but we know that those usually comes out in AMC, not Olympiad. So, and if we're going to do more on number theory, I need to study more on like uh, other stuff like Diophantine equations, Pell's equations, but they're just like too much things to study. But for geometry, if we I think over the past few years I dedicated my time on geometry, so I kind of have like that grasp on how to solve like few problems in geometry. And I also know more theorems in geometry than other threes. So that's why I'm going to concentrate more on geometry. And it's also usually on problem 1, 2, or 5, 6. It comes out in 7 and 8, but I don't think that will happen this time. I don't know. And for algebra, I just like algebra, and like geometry, usually spend my time on algebra too, so that's why I'll be focusing more on algebra and geometry. So for my future videos, if you don't see combinatorics or number theory, like, I think this explains why. So yes, thank you, and good luck to everyone who is preparing for Olympiads and other math competitions. Okay, then without further ado, let's start this problem. Let A be a triangle with angle A 90 degrees. So we have, I don't know why, but it's just so hard to draw on pads, on like paper. Oh, that's so. Why is it so wiggly? I think I need to redraw. Like just draw it. The right angle here. A, B, A, B, C. Point D and E lie on AC and why is my B up there? I mean, it doesn't really matter. I think I will just go with this. Okay. AC, AB, such that ABD, ABD, DBC. Oh, so it's an angle bisector. Like this. So this point right here is D. And ACE, ECB, so it's also an angle bisector. No. This is E, and they meet at I. So we know that I is in center. We know that I is in center. Determine whether or not it is possible for AB, AC, BI, IB, CI, IE to have integer lengths. So we want to know if what? Why can't I? Wait. Oh wait, we cannot highlight it. That's unfortunate. Okay. We want to see if it's really strange that you cannot highlight vertically. AB, AC, BI, so this one. BI. ID. So the highlighted ones to have integer lengths. The official solution, I found it really like somewhat fundamental but also elegant because they used a very, 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 very special thing. So I was so when I first looked at this problem, I thought of drawing an incenter and maybe a circumcenter because this is right angle. And then I was trying to like extend few lines and like try different cases. But then after looking at the solution, I was like, it is quite obvious why we should do that, but I was not expecting it. So when we usually think of law of sines and law of cosines, I think I need to break the stereotype that law of cosines and law of sines usually comes out only in AMC, not in Olympiads. But this problem broke the stereotype, so I should be reviewing more. So we're going to assume that AB, AC, AB, AC, and BI and IC integer. Then what we can do here is let's oops what Yay. So we're going to let this be theta, and this angle be theta. Then we can rewrite these two angles. And we know that so what should we try? We can rewrite these angles, and the way to rewrite this angle is using different like in terms, we can write these two angles in terms of theta. And we're going to do that because we want to know the angle of this. Okay, so we know that this is, let's just write what we know. This is 90 minus theta. This is 90. Okay, this is 90 minus this one. We need to know this one. Okay. Okay, before doing that, let's okay. So before doing that, let's use the entire angle. So we know that this is an angle bisector. So to theta over 2 equals 45 minus theta. So this, oh wait, yes, this is 45. 45 minus theta, and this is also 45 minus theta. Now it is quite self-evident that this is 135 degrees. Then let's use law of cosines for BIC. So we know that cosine of 135 degrees. It's been so long since I didn't use law of cosine. Okay. I think this is correct. Yes. Over wait, it was this squared, and this squared, right? So bi squared plus minus bc squared. Now notice that this is what is cosine 135? The sine negative 45 degrees, right? Which means it is negative 2 root 2 negative root 2 over 2 is equal to bi squared plus ic squared minus, what is b squared? Bc squared, ab squared, and ac squared. bi, ic, ab, ac are all assumed to be a positive integer, but dividing an integer by integer cannot lead to any rational number. Therefore, by contradiction, so because we know that this whole expression right here must be a rational number, but it turns out to be an irrational number, we know that there is an error in our statement. But this is this and these are the same condition, so that means this statement must be false. So the problem is if AB, AC, BI, ID, CI, and IE to all have integer lengths, but we don't really have to look at EI and IE or an ID, because we already know that these four all cannot be an integer. At least one of them must be um, a, an irrational number. So I found this problem really interesting and amazing because uh, like law of cosine, it just felt like an elementary principle that we learn in high school math or even like in middle school math, but uh, I was not so I didn't expect the law of cosine to be used here, and also um, the tracing the angles led to the usage of it. So although the solution was quite short, I think like the idea and maybe like psychological effect behind this problem was what was really interesting to me. So thank you so much for watching this video. I hope you enjoyed it. And tomorrow I'll come back with another very fun and interesting problem. And thank you and see you tomorrow. Bye.